Saishriya, Satya, and welcome to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Advanced, and we're going to be learning about probability. So let's get started. So probability is a mathematical measurement that tells you how likely or unlikely an event can occur. And probability is equal to the number of favorable events over the total number of events. If you don't understand, that's okay. We'll help you with some simple example problems. When a fair coin is flipped, what is the probability of flipping heads? Well, we know that the denominator has to be the total number of events. And a fair coin, has two sides, heads and tails. So we know that our denominator has to be 2. Out of those two outcomes, heads is only one of the outcomes. So the probability of getting heads is 1 over 2. So P of heads, this is how you would write it, is equal to 1 over 2. Now let's move on to number 2. If a jar contains 3 red balls, 5 blue balls, and 2 green balls, what is the probability of picking a red ball at random? Now we know that the denominator is total number of events, so let's count how many balls there are in total. 3 plus 5 is 8, and 8 plus 2 is 10. So the denominator is 10. Now out of all of these balls, only 3 are red, and since we're finding the probability of picking a red ball, 3 is going to be our numerator. So probability of picking a red ball, which we write as R, is equal to 3 over 10. And if you want to simplify further, then you would get a decimal 0.3, which we can convert to a percent, which is 30%. So the probability of picking a red ball is 30%. Now let's move on to independent events. What is an independent event and how does it occur? An independent event is when two events have no influence on each other's chances. Then they are known as independent events. And here's a note that you guys might need to know. The probability of two independent events both occurring is the probability of the first event multiplied by the probability of the second event. And this note is going to help us with the example problem we have here. Let's go ahead and read it. A jar contains 3 balls, 1 red, 1 blue, and 1 green. 2 balls are picked at random, each one being replaced after it is picked. What is the probability that the first ball picked is red and the second ball isn't? Let's first go ahead and find the probability of the first event, which is picking a red. We know that there are 3 options since there are 3 balls, and red is one of the options here. So let's go ahead and write that down here. I'm going to use a different color. So let's write red. Now the probability of getting red is 1 out of 3, since it's one option out of 3. So this is the first event here. I'm just going to go ahead and label it. Now let's find the probability of the second event, which is not getting red. And we know that there's 1 red, 1 blue, and 1 green. Now we can obviously tell that these 2 options are not red, which means that there are 2 options that are not red out of 3. So the probability of not getting red is 2 out of 3. And this is the second event. And we know that to find the probability of 2 independent events both occurring, we have to multiply the probability of the second event by the first event. So that being said, let's first multiply 1/3 by 2/3. One times 2 is 2, and 3 times 3 is 9. Therefore, the probability of getting 1 red and 1 not red is 2 out of 9. So now let's do some challenge problems. What is the probability of getting exactly 2 heads out of 3 tosses of a fair coin? Now to solve this problem, let's make a tree diagram. So on the starting, we have a T and an H, representing tails and heads. Now we can branch out and have another T and heads, tail And we could have another one for each of these. Tails, heads, tails, heads, tails, heads, tails, heads. Now based on this, we can create our 3 tosses. So for the first one, we have a T, T, T. Next one, we have a T, T, H. And so on. So then we could do T, H, T. And then a T, H, H. H, T, T. And an H, T, H. And finally, an H, H, T. And an H, H, H. Now, is there any more that we can do? So, in total, we have 8 possible combinations, or 8 possible events. So you know that our denominator is going to be 8. Now, what is the question asking? Well, the question's asking exactly 2 heads. So let's see, out of all of these 8 possible events, how many have exactly 2 H's, representing heads? Now, this has 3 T's and no H's. This only has 1. This also only has 1. And this has 2. So this is one of them. This only has 1 head. This has 2 heads. So this can count. And this one also has 2 heads. Now this has 3 heads, but it has to have exactly 2. So this one also does not count. So in total we have 1, 2, and 3. So the probability of having exactly 2 heads is equal to 3 out of 8. Now let's look at the second one. If 2 standard dice are rolled, what is the probability that the sum of the 2 rolls is less than 5? Now over here I created a chart to show how many, or let's say that this is the first dice, and this is the second dice. And this represents, the first one represents the number rolled by the first dice, and this number, the second one, represents the number rolled by the second dice. Now, what we have to do here is we have to look at all these numbers and see which ones have a sum that is less than 5. Now, we know that 1 plus 1 is 2, and that's less than 5. We know that 1 plus 2 is 3, and that is less than 5. We know that 1 plus 3 is 4, and that's less than 5. And 1 plus 4 is 5, and it's not less than 5. So that is not also, so these do not count. Now this is less than 5, 3 is less than 5, and 4 is less than 5. But 5 is not less than 5. Now over here we know that 3 plus 1 is 4, which is less than 5, and we know that 3 plus 2 is 5, so this does not qualify. And we know that if this is the only one that qualifies for this one, none of these are going to work. Now, let's first look at the denominator. We know that there are 6 possible options for the first dice, and 6 possible options for the second dice. So in total, we have to multiply 6 times 6. And we know that that is 36. Now, we also know that only some of these have a sum that is less than 5. Now we have 1, 2, 3, 4, 5, and 6. So 6 over 36. Now can we simplify this further? Well, we know that it has a common factor of 6. So this will become a 1, and since we're dividing 36 by 6, we get 6. So our answer is 1 over 6. So the probability of getting a sum that is less than 5 is 1 over 6.
Now let's look at some challenge problems in probability. Suppose you can choose from 3 different shirts, white, blue, and black, 2 pants, blue and black, and 5 pairs of shoes, formal black, formal brown, sneakers, running shoes, and boots. What is the probability of wearing an all black outfit? Now we need to find out the probability of getting black in each outfit or in each section. So let's first start with shirts. So we know that there's a total possible outcome of 3 since there's 3 different shirts. So let's go ahead and first write shirts. And so we're finding the outcome for shirts. So we're finding the outcome for a black shirt. So we know that there's 3 total possible outcomes. And out of those 3, black is one of the options. So the probability is 1. Now let's move on to a pant. Now we have 2 options, 2 pants. So we know that it's out of 2. And out of those 2, black is one option. So it's a half. Now let's move on to shoes. In shoes, we have out of 5 pairs of shoes. So it's out of 5, and out of 5, black is one option. Now, to find the probability, what you have to do is multiply all of these probabilities for each different section. And the reason why we're multiplying is because each of these probabilities are for different sections. They're not the same thing. So let's first multiply 1/3 into 1/2 into 1/5. Well, we know that the 1 stays the same, and we can 3 times 2 is 6. So it's 6 times 5, which equals 30. So we get a total of 1 out of 30.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!